say something?
Well, so where are you guys from? So it looks like there's 7 here today.
Yeah,
where are you guys
we're
from?
definitely light. You know, we didn't think about the fact that it was the beginning of March Madness tonight, and we think that kind of killed our crowd.
Yeah, we usually have about 20, so my apologies. Don't take it personally, but yeah, we think it's March Madness.
That's
Okay.
But I did have somebody, email me today asking if we were going to record, and so there's always at least one of those, and so hopefully there'll be some other folks that'll watch the recording too. So.
Yeah, definitely.
But Mark is with EvolveLab. Actually, I'm going to let Mark tell us a little bit about EvolveLab because I don't even know how many people they have these days. I've known Bill for a long time, but I don't know how big their crew is and how much of their work is Dynamo and how much of it is other things. But I know they do a lot of different kinds of consulting and training too, I believe. Right, Mark? And they agreed to share with us some work they're doing in Dynamo. And so I'll just let Mark take it away and tell us both about the company and then what he's going to show us tonight. So thanks.
Okay, awesome. Thanks. Yeah, and thank you, Paul, for inviting us. So to start off kind of about the company, we do BIM consulting, all the way across the from conceptual design to facilities management, like across the whole entire spectrum. We do like template stuff for all the different disciplines, and we do training for all the different disciplines, and we do software for all the different disciplines. Like we just do a lot. We just problem solve like whatever clients want or could provide value to them. Then we'll typically try to give them like a feasibility versus like value versus investment kind of idea, and try to make sure that everybody can be happy like with any service that we want to provide them or that they would like us to provide them. So I'm not usually the EvolveLab spiel guy, as maybe you guys can tell, but I usually, so like, yeah, a lot of my day is spent doing Dynamo. So there's like, weeks at a time sometimes where I'm just in Dynamo, like for the whole entire time, like 40 hours a week. So that's why I'm here. I guess I'm going to show you guys some cool things. So to start off, I try to gear the idea about like for this webinar or for this Dynamo user group to be like an introduction to geometry. So in my mind, and I'm not sure your guys' backgrounds that much, but I kind of figured that you guys would be like, in positions where running like feasibility checks or trying to look into things that are feasible or not feasible or trying to prototype in Dynamo would be kind of your guys' forte, or at least people would lean on you guys to kind of look at those things. I don't know if that's wrong or not, but in that vein, I'm going to go through kind of like starting to mess around with some of the geometry nodes. So these are things like dealing with points, curves, and surfaces, and kind of the corresponding nodes that go along with them. So the reason I say like this thing is kind of important is that I see these things a lot. So I see the use for what I'm going to show you today, like a lot. Like I see it almost every time I touch Dynamo, and for a lot of different clients. Like if you're trying to do anything that has any sort of physical aspect within your model, like any sort of data management with that, then it's going to be required that you know some geometry tooling, whether that's like panelizing a facade or if you're trying to do like quick things and try to make your life easier because you know that there's some like physical correlation between the data and the location of the element in the project. So to start off, like kind of the idea that I'm gonna go with, and so if you guys saw like the agenda for the day, it's related to renumbering with a spline and then using this custom package called Firefly. And so that's kind of like the holistic view of what we're doing and kind of why we're doing it. Is there any questions about that or anything you guys want to comment on?
Sounds good.
Good.
Cool. All right. So so to start off with, I'll just draw this spline so that we can start to get an idea of what this is going to entail. So can you guys see my Revit?
Yep.
Cool. So I have like all of these parking across here, and I just set all of their mark values to 0 just so that we could renumber them by spline. So like we're just going to say like we want all of these things to be numbered. Like this will be 0, and then you'll come all the way across, and this will be like number 12 on this end, and then say like this will be number 13, and then we'll come across and this will be like, 21 or something, whatever it's supposed to be. And so if we want to do something like that, and so renumbering with Spline workflows are pretty common, especially like when it comes to using things with like sheets and views on sheets. You can renumber those really easily. You could do things with parking really easily and rooms really easily. Like if you have some sort of correlation between, say, like your room and where your room is in the project, and then where what the number of the room's going to be, then you can do that pretty easily. So I like hid this roof, so you can imagine, like, if say there's some room up here in the top right, and if you want that to be like, I think this is going to be like, I don't know, the second level or something. So if it's like 200 here, then you want it to go like in sequential order all the way through here, and this will be like 210 or something like that. And instead of manually doing it, the idea is that you'll be able to like just take a spline and just do something like this, and then you can analyze that spline using Dynamo and then renumber all of your rooms based on that spline. So you would do something like that, and then you can just like run your script and it'll renumber all of your rooms. So I'm just going to do it with parking though, because I was recently working with parking, and one of our clients had like one of these scripts. I didn't see the script, but I thought the idea was cool, and that presenting about it would give a good entry point into introducing how to start working with geometry and Dynamo. And so like to start off with, we're going to try to think about like where on this spline are these parking stalls located. So this one's very close to the beginning, and this one's very close to the end. And so the idea is like, well, how do you like measure like what's at the end and what's at the beginning? And so kind of the idea of this is to use it's called like parametricism, but it's in a different vein than like typical parametricism that we see. So if we come into geometry and we start to look at like our curve, well, I'll make a line first just to get it started. So I could just grab some like points and plug these things in and say like just make a line that just looks just like this, nice and straight across. And so what it's called is called like a parameter or parameterizing, something like that, like of a curve. So if you take the curve, you see like right away like within curve, and you'll see the same thing within surfaces and within like a lot of different primitive geometry shapes that you have these things called parameters. So it's like normal at parameter or horizontal frame at parameter. And so like if you say something like point at parameter, then if you pass your line into here, then what this point at parameter node does is it says like, okay, let's make the line into its own coordinate system. So the beginning of the line will be 0, and then the end of the line will be 1. So if you go ahead and do something like 0.5, then you can see like a little point was populated right there on halfway through the line, 0.5. So you see 0.2, and you change it, then it comes here. So so what I want to show here is, and so this is a good, this is a good leeway into describing this process like visually. You can use this package called Firefly. So I want to. So one thing that I highly recommend and is that you start to use the manage node and package paths for different custom packages. So like this is kind of an aside, so let me just digress a little bit here. And so whenever you have like a lot of custom packages on your machine, then your search in Dynamo goes like to heck. Like you can't find anything anymore. Like if you have like all of the most popular packages in your Dynamo, and then you try to like right click and search like get parameter value by name, you have to type in like the whole entire thing in order to get like the node that you want, and that's like miserable for me. And a lot of times I don't use custom packages, so I highly recommend like going for like custom package paths and things like that, and that'll get you guys like really far. So if I come, I'm just gonna come over here to like my app data directory, and because I thought that I had like Firefly and something separate, but I guess I didn't. So I'm just gonna come over here to my packages, and it's just gonna load all these packages really quick on the left. And so Yeah, well, that figures. I didn't get Firefly back, so I'll just go look for it. So there's a package called Firefly, and it was on my machine at one point, and now that I'm presenting, I guess it's not there anymore. But so bear with me here. I didn't expect this. I'll have to go ahead and download Firefly as I can.
You change your path to your packages frequently. Is that what I'm hearing you say?
Yeah, I pretty much I do it very explicitly so that I can try to get like only custom packages I need, but more often than not, like just try to make it so that I don't have to worry about my custom packages at all. Oh, wow. Okay. I'm not sure where Firefly went. What is going on here?
Try hitting backspace once.
Oh, here it is. Yeah. So this will go pretty quick. There you go. All right, cool. So I got Firefly now. So Firefly is a custom package. It's typically used with like Arduino. It was originally a Grasshopper, like special package or something like that. And then they had like the Firefly team has like this whole like Grasshopper to Arduino framework and infrastructure setup. And so they went ahead and ported some of their stuff over to Dynamo. And so I don't use like the Arduino stuff very much. I did a lot of Arduino stuff in college, but so essentially what we can see here is when we drop this node on the canvas, then we're going to get the periodic option. So like it's pretty cool. Like if you look at the Dynamo code base, you can see that like you can tag specially like certain nodes and say like periodic enabled essentially. So like whenever you drop a certain node on the canvas that allows for periodic, then it'll enable itself. It'll like realize that there's a periodic node on there that you can use, which I don't know if you guys are interested in, but I thought that was pretty cool. So I'll just say like go from 0 to 1, and then this thing it kind of works this way. So if you have something like this, then it's going to like continuously run across, and so you'll put in your numbers like this. And so like to kind of unpack this a bit, so right, and I'll just back up one step just to make sure that like everybody's on the same page. So right now what I'm doing is I'm trying to run an animation that'll show like how the parametricism of a curve works, so that you can kind of start to see like what it means to define like the start of a curve and the end of a curve, and how to access the points along the curve for that curve. So so like you can see like that this thing is climbing, this number is climbing by 0.1, and the 0.1 just comes from this. So there's like this, this is telling Dynamo like rerun this event every second, or like 1,000 milliseconds, and then this one's telling it like run it every, or then chop it like up like 10 times. So it's going to just be skipping on 0.1, and so like you can take that number and then you can plug it in over here instead, and then what you can get is well, yeah, let me just cancel that real quick. I think my pointed parameter notes just second. Well, what a bummer. Okay, well, here, I'll come back to Firefly in a second. I might have to drop it on the canvas first, actually. So I could show it with like a helix really quick just to do something from this. So if we go ahead and say like curve pointed parameter, then we're going to be pulling all of the points here. So if we watch down here in the geometry preview, we can see that this node, this little point, is like climbing up this hill. And we can make it into like a sphere to just show it a bit better. And make it like a pretty small radius. And so like in one way, this is like how you could start getting started with like doing animations and different things like that in Dynamo. If you've seen stuff like that, like, so you can start like animating like rotations or folding things and stuff like that. You can also start animating things like creating perspective views. So you can say like you can draw a spline and then you can run along that path while making perspective views and like taking screenshots so that you can start to like make GIFs of like walking through certain parts of your building really easily. Some clients like it, and so I figured maybe if I showed this to you guys, then you guys can carry it away somewhere or do something with it. And so does anyone have any questions about this? It's kind of like, you know, as this value climbs from 0 to 1, it's going from the beginning of the curve to the end of the curve.
Why is that called fader? I'm trying to figure out. I mean, it's not important, but I'm just wondering what that name means.
I think it's just like you know, fading from fading to. So
yeah, okay. I mean, it seemed just. Yeah. It's not important. I mean, it's just yeah.
Yeah, no, good question. I like it. It's fine. So then yeah, so like I guess coming back to our original idea of trying to renumber all of these parking stalls with this spline is first off we'll just grab the spline. Which we could just use like this select model element node. And we'll click on the spline and then we can see it come in here. And there's our detail curve. And so what we want from it is essentially, we'll also grab all of the parking stalls. And so here in Revit selection, we can do like all elements of category, which I imagine most people are familiar with. And we can grab like all of the parking. And from that, we kind of just get all of these parking stalls. We can like click on this element ID and it kind of will zoom into like one of these parking stalls and we can kind of confirm that that is what it's doing. And so then past that, we can get the curve from the detail curve. So like the detail curve is just like an element in and of itself that's going to have information related to like anything that's here, like line styles, and if it's like symbolic or like a model line, things like that, or if it's like symbolic or like a detail line, you can kind of start to get into that when you're using stuff coming out of families. But we go ahead and we do our curves, then we can see that our parking curve came in right here. We could do something like pulling element geometry from all the parking elements, and this might run for a second, but then we can see like that this is indeed like that spline that's just chopping through all of these parking stalls. And so if we want to get like where these parking stalls are along this spline. And so first thing we will want is just to get like the location of all the parking stalls. So this get location node is pretty good. It tends to like have like a weird interaction with structural stuff. So like if you're working with structural framing or columns or things like that, sometimes you have to go about getting those lines in different ways, like going with element geometry or doing like element curves or something like that for like structural frame or like a beam or something like that. You won't necessarily always get back like a location from that kind of stuff, but it you know, maybe that's helpful like for anyone that wants to work on that stuff. So so I'll go ahead and hide like the parking stalls, and then we can see that now we have the location of all those parking stalls, like as they're kind of laid out. And it looked like it was, well, the get location is going to give us back the point in like wherever the placement point of the family instance is. So wherever it was built or however it was built, that's kind of the point we got. And it looks like we get like maybe like the bottom right corner or something like that of every one of the stalls. And so if we want to get its location, well, yeah, if we want to get its location relative to the spline, then we get we have like another pretty nice node here called closest point to. And so we can pass in our curve, and then we can pass in our points. And so like if we run this, we'll only get back 1 point. So we have to make sure that we do lacing longest so that, yeah, and I'm not sure, like I don't necessarily want to dig into lacing too much. I bet like Paul did like a really good job like explaining it at his BIM workshop at AU this past year. So is that true, Paul? Did you go over lacing?
I did go over lacing. Yeah, not everybody here was there, but yeah, we went over that. I think everybody in the room probably has got some concept of lacing, so it's fine to
Nice.
to do that shorthand if you like.
Cool. Yeah. So yeah, we'll go ahead and we'll do like longest lacing, and then we see like we get all these extra points. So pretty much what we will see here is, and let me go zoom over into this corner, because this is kind of like where everything's going to happen is that like all of these parking stalls, they all came in kind of randomly, like however it was pulled from like the element search. So it looks like they're all sorted by ID or something like that. And so that's not necessarily helpful for us. And so like the first point here is just the first point is this parking stall here. So you can see like everyone is kind of right across from each other as it's all laid out from like just using this closest point 2. So this is like the next point in the closest point 2, and that's like the next point. So they're all kind of related like this. So because it's the closest point to where the parking stall is located as reflected onto that curve. So we get all of those closest points, and at this point we can just hide the geometry preview of the parking stall locations, and we'll be fine with that. And then now that we got these closest points to, we got all the points along this curve. So this is kind of like the opposite of what we saw earlier, because earlier we saw that we're looking more for a point at a parameter. So we could give it a value of say like a quarter, and then it says like a quarter of the way along this line, tell me what point that is in space, in like the world coordinate system, like in all of Dynamo, where's that point located, or all of your project. And so now instead we're looking at like what's the parameter at this point. So if we say like parameter at point, we have there's always like a surface and a curve representation of these, and we'll check out the surface one in a little bit here, but we could get the point, and then we can pass our curve back here, and then we'll get all these parameter values with longest lacing, and we'll get all these parameter values. So like just to like unpack like what all these decimal points mean, it's essentially like how far along this curve it is. So if we go with like something that's really small, like say this one for instance, like number 16, then yeah, see, so 16 is going to be right here at the very beginning because it's like very close to 0, and then like I guess number 17 is going to be a lot farther along. It's going to be at 0.9, a lot closer to 1. And so we know that this is kind of what we have to sort by. And so there's two like really awesome nodes that are super important. Like I use them all the time, and they're like sort by key and group by key, and they're pretty similar to like a filter by bool mask, where you hand it all of these values, and then all of the values correlate to elements in another list, and it kind of sorts the first list and then sorts the second list in the same order as it sorted the first one. And so like with so just to do it explicitly, like we'll say that our keys are going to be all of these values, like all of these values that from 0 to 1, those are all of our keys. And then for the list, we'll go ahead and say that these are going to be our parking, because so then it's going to say like, okay, well, let me just sort out this list. So it's gonna sort from like 0 to 1, you know, kind of ascending, and then however it sorts out these 27 elements, it's going to do the same thing with these 27 elements. It's going to switch them all in the same order. So when we run that, we'll get all of our sorted keys on the bottom. That'll be a second output. So you can see that like it's from 0 to 1 kind of in this ascending order. And then on the top, we have all of the parking that's kind of arranged in that same way. So if I go ahead and grab this element geometry node again, we can see that the way that all of the parking kind of laid itself out. So if I just pull this off to the side, then we can see like that the first element of the list now is the first parking spot, and then the second element of the list is the second parking spot. And now we can see that everything is sorted based on the parameters of the spline that we drew. Is there any questions about that? Nope. All right, nice. At this point, we can do it a couple different ways of how we're going to like figure out the numbers for these parking stalls and then applying them to the values. And so a cool way that I found that you could do this is if you do get keys. So I don't know if you guys have seen this node either. If you just do it on a regular list, it gives you back like the indices of the list. So it'll give you back like 0 through 26, which is the same as like just these indices. And they also have like a get values node that you could use that gives you back like the actual values of the list. So this will give you your families, and then you could use that to like, I don't know, make a dictionary or something, or try to, you know, otherwise organize your data more explicitly now that you got access to all their positions like within the original list. And so when you get all of these keys, now you have like all of the values essentially that you need. So you can do something pretty easy like get parameter value by name and set parameter value by name. And you just can pass this in. I made a parking tag, and it's just based on mark, or it was like the out of the box tag. It's just based on the mark. So I'm just gonna push this into the mark value and pass the parking stalls in there, and then see where it goes. And I think we might need, oh yeah. So this says that the parameter storage type is not a number. So mark is like a type parameter. So if I say like get parameter by name, oh, actually it's just like parameter by name. Yeah, this is something like I always show people, is that like one like really powerful aspect of when you're working in here is that there's like an element.parameters node. So if you have like Revit lookup or something like that, you can use that. And so like if I select this parking stall and then I go to my Revit lookup tool, I could do like snoop current selection, and that'll just give me access to all of like the database entries that are corresponding to this element. So, you know, I could get stuff like information about like, well, how do I retrieve location, or how do I get like the level of this element, or, you know, anything that's not going to be like readily apparent just looking at it, like especially things like facing orientation. Like if you want to start to automatically place things like outlets along walls and stuff like that, like you're going to have to deal with rotation quite a bit. Same with like when you're like panelizing things, or you're working with like curtain panel workflows and you're trying to see like what is the best way to like rotate panels into position or something like that, then like looking at stuff like facing orientation and stuff like that isn't really given to you through Dynamo. So you can kind of start to look at the back end of what the database entails. So if I use like, but if you don't have Revit lookup, then if you use the element.parameters node, which I just passed in all of the parking stalls into, then you can see like all of the available parameters that you have for your parking stalls. And so say like for mark, it's right here. So it's like number 2. So if I do get item at index and then I just pull out number 2 at level 2, that will give me all, yeah. And I can pull out the mark value or the mark parameter. And so now I have access to like all of these parameter nodes based on, so I could check out like what's the parameters group, or, you know, the storage type is what I was going for. Because we got this warning earlier that said like that the parameter storage type is not a number because we're passing in these numbers here. So if we go and we look, then you can say like, oh, okay, the parameter storage type is actually a string. And so like recently I did quite a bit of work for clients that related to like making really solid like interoperability with Excel workflows, because I think like more and more, and I'm fairly sure that this is a way the industry is going, is and I could be wrong, like because when Project Quantum starts to really like surface itself, it's going to start becoming something where your data is much more easily like editable and accessible. Like where right now, if you want to edit data in Revit, you kind of have to know Revit in a lot of ways, like to be able to navigate to views, to see the proper elements, to click on them and to edit values, or you have to go to your schedule and editing like tons of values and schedules is like really hard, like especially for structural firms. It's like they have like 1,000 beams or something, and to like edit every single value of the column, you know, there's no like select all, like that's very easily. So you can export everything out to Excel, and then like a project manager or whatever can edit all of the information, and then you can import it back in. So whenever you're working with workflows like that, you got to be really cognizant of parameter storage types. So that might help, like if you are working with some sort of Excel interoperability workflow, and you're getting a lot of errors related to that stuff, this could be a good way to go about it. So once we know like that actually has to be a string, we could just do like object from string or string from object, and pass that in, and now we'll see that we have the numbers. But if we do like object type, then we can see and just make sure that there are strings that are being passed out of here, where before it was numbers, well, integers, I guess, in this case. Yeah, so once we got all of these strings, then we can just pass these in here instead, and we can go ahead and set it. And I guess it runs with no errors, and it looks like everything is there. And so if we go ahead and we check it out, then this one's like mark 0, the mark value is 0, and the mark value is 1 for this one, 2 for that one, 3 for that one, and all the way to 26. So in that way, we're able to get everything going and renumber everything by spline. I'll try to just like apply these. Yeah, and we can see like that was successful. Are there any questions about that?
So the reality is you would never mark 0, the first one. How do you start on 1?
Nice, good question. Yeah, so you could do things like really complicated and do it that way, or you could just do like use a plus node, and you can just say like +1, and that'll start from 1, and you click it, and then you can start from 1. Good question. Does that answer your question?
Yeah.
Nice. Let me think. Yeah, so I have like so now the next way I kind of want to go about it is to look at placing these tags automatically, because for something like this where you have all of your parking at 90-degree angles, it's very easy for Revit. And well, I mean, I shouldn't even say that. I should say that when Revit does its tag all not tagged, it can be very hit or miss. And I'm not sure, like, you know, on what level you guys are testing that out or checking it out, but especially for angled parking, like I've recently dealt with like some really complicated angled parking that has like a whole bunch of trig in it, but essentially like you know, and it has like big like detail masks and stuff like that really like show all of like the aisle, you know, or drive width and bay width and all of that stuff, and like car door like width, like clearance and stuff like that. And so once you get to stuff like that, then you're really trying to think about how do I make the workflow for my parking as easy as possible. And I think that sometimes you can do stuff where you like nest the tag within the parking family, but that comes with like its troubles and things like that, but could be successful that way. But if you, so I guess there's a bunch of arguments either way to like using parking tags versus nesting the tag within the family, or nesting a generic annotation within the family. Paul, I'd be interested in hearing your comments about that, man, or anybody else's. Do you guys do your parking any certain way?
Parking specifically, I mean, I don't have a specific example about that, but I'm not really a fan of nesting a tag into a model. I think there's too many downsides. But possibly the only exception that is commonly used that I'm aware of is you know, outlets and stuff like that, because you want the scale dependent feature of the generic annotation. But as far as trying to put a lot of text in there, it often has more trouble than it's worth, if you ask me. But you know, that's what tags are designed for. But there's always exceptions.
Yep.
There's no hard rule. So you know, that's always the first thing I tell people. So
yeah, for sure. I 100% agree with that. And so Yeah, so I guess like the next thing I want to show you guys is if we want to say like place all of our parking tags like a little higher or something like that automatically, how we would go about starting to do something like that. And I think this is very relevant also towards like automatic placement of like room tags and stuff like that. You know, I think it's always something where different firms have different workflows. So some people are like, well, I don't want to automate tagging. I'm just going to do it myself. And other people are like, well, it's nice to just have the tag in the room. And it'd be nice if, you know, it could just be placed this way by default or something like that. And so, well, actually, I'd also say so yeah, that's the goal, is to just say like, how are we going to start more specifically placing tags onto elements across our project using Dynamo and kind of managing that workflow. But I'd also say that this is a pretty good opportunity for doing something where you augment your family to correspond with your Dynamo workflow. So if you don't want all of the tag information within the family, you can do stuff like create like a little crosshair or something like that, like within your family. And then when you could use Dynamo, and then you grab that crosshair out of there, and now you have like the specific point to place your tag. And so it's nice with tags, right? Like you could do something like that. You could also do stuff with detail items and things like that. But where I've seen it be absolutely killer is with auto-generating section views and 3D views for objects. Just because when you want to create a section view for any sort of object or like a 3D view, you have to have there's a certain minimum of geometric information that you need when you go to do something like that, you know, because like when you create your section view, you need information about like what's the up direction. Like you have to make sure that your section view is like looking the right way, and that it's like oriented the right way kind of in space, and it's not like rotated off to the side. And none of that stuff comes for free. And you also have to make sure it's rotated correctly, because if you know, like if you just try to use say like a bounding box or something like that, and I'll just pull out the nodes really quick so that I'm not just like talking about it, and I could just show you guys like what it means. Is that if you go to do like a section view, Dynamo gives us like these two tools here, and they're called, there's like section view by bounding box, and then section view by coordinate min point max point. And so it's something where like you can get away to a certain extent with like doing something with a bounding box, but you won't. But like you almost always have to go with this workflow of using this second node of by coordinate system min point max point. And so I'll just unpack it a little bit just because I think it might be helpful. But for the most part, I won't dig too far into like how we're going to do this. So like when we make our coordinate system, we kind of define like what's the up direction, what's the right direction, and like where's the section view located, and then like min max point kind of judge like that far cliff offset and things like that. And so like you have to like you can like explicitly set all those things, or you can like implicitly set all of them with the by bounding box node. But once things start like rotating, then like the bounding box doesn't rotate with it. The bounding box will stay in its one spot. So you really have to like find out all these little pieces of information, like and they're all related to just like vectors. They're all just like vector relationships and things like that, like when you come to x coordinate and y coordinate. So all this to say, like if like augmenting your families for use in Dynamo is like really, really powerful. And I'd say like always, if you're doing a workflow where you're auto placing stuff, or you're creating if you're doing anything where you're making geometric assumptions, or you need to have geometric information about what your script is going to do, like always think about like just adapting the family rather than trying to get all of that information out. So like one thing is like with glazing percentages, like a lot of people have really good glazing percentage workflows. So I would always like push back and say like, you know, check and see if you could do it out of the box first, like with schedules or something. But in some cases, it's really easy to just define like two parameters that say like this is how much glass is within this family, because you know, say they have like family instances for each like panelization of a facade, or each like structural frame or something like that. It's much easier to just like put the information about how much window there is in the family and then just read that information out with Dynamo, rather than querying for all the element geometry and then looking through the element geometry for all of the materials that are assigned to every element, and then filtering out any faces that are looking in the wrong direction. So you get just like the glazing percentage faces that are going to be accounted for. and like doing all of this workflow. So it's a really powerful tool, and I highly recommend, like, yeah, if anybody like tries something like this where they're doing something where they augment their family, I'd be excited to hear about that. So I did one too where there was it was a big data center project, and there had to be a lot of cable tray like routed like specifically around like these servers like that were all stacked in a row. And so inside of the family, which was like super parametric, so you can make like, you know, a 30 row long data center like server row or something like that. It just put like this really simple like dashed line around it, and you just query it out with Dynamo, and then you can draw this cable tray around this really easily, and it all like updates and it all works really well. So yeah, kind of a tangent, but maybe it's helpful, and I'm sure it will be at some point. So the last thing I'm going to show you guys is kind of like tagging all of these things without using tag all, not tag, and we'll just kind of see like how we start to take a look at all of this stuff and what we do with it. So now that we have all of our mark parameters set, we can come back, and I guess we don't need our spline anymore. Just run it. Yeah, it looks like all the mark parameters are still good. So we have like a tagging node here in the Revit out of the box stuff. And we could say like by element and location, or just by element. So we'll go ahead and do like just location, and we'll get like an active view. And there's like good ways to get like things like active views, and there's like not as good ways, because active view doesn't reset very well. Well, actually, I think it's like the current document doesn't reset very well when you're using Dynamo, like when you're rerunning and stuff like that. It doesn't like reset automatically always, which it might in Dynamo 2.0, but for now it doesn't. So if I just grab like this active view, I'll just do it this way for now, and this is just like on my site view. So yeah, that's the one we have. And so then we want to pass in all of our parking elements, and then we want to pass in locations, and we want to we won't do the leader line. So the default value for adding the leader is false, so we don't need to worry about that. And then we'll just need a location. So this is kind of like where we're going to be doing things. So we can start off by just passing in the location that we had originally, which we know is kind of just like the placement point of the family. Probably not that useful. Let me just like delete these tags really quick so that we can start fresh. And then if I run this, we'll get all of our tags placed like right there in like the bottom corner, like as we saw earlier where our get location was at. And so if we want to start to place them like more in the middle, more centered and things like that, like how would we do that? That's kind of the goal. And so I'm just going to freeze out the tagging node, and I reran it so all of my tags went away. And so like this is a cool trick, and you saw it here first. So let's see. So if we do like a bounding box around of our element, and I mean, there's not like a whole lot of intuition behind this stuff except like kind of just dealing with it before and using it before. And then we get like a cuboid from a bounding box, which is always like a pretty typical workflow when it comes to this stuff, like finding heights and things like that. So now that we did that, we see that we kind of have all of these set. Like we have like just this small like thin box like around each one of our parking stalls, and it's not very tall. I think it's like 0.01, because there's not a whole lot of like height to any of these parking stalls. And what we can do is we can like intersect these with a plane, because what we want is we want surfaces for each one of these parking stalls. Because if we have surfaces for the parking stalls, then we could use like a point at parameter node to start to get information about like what points are available on each one of these surfaces for us to like place things at. So if we look at here, we have this point at parameter, and so it takes in like these UV coordinates. So you can kind of imagine that like if it's like a square, then like 0, 0 is going to be like in one corner of the square, and then with the UV values of 1, 1, that'll be in the top corner of the square, like in the other side of the square. So but we want surfaces, and right now we just have boxes. So if we try to do like a point at parameter with a box, it doesn't really make sense. And so what we can do is we can just get a plane and pass this plane into here, and we might have to do a lacing loss or something. But Let's see, where's our, yeah, our plane's right there. So let's see, we could do this location. So we want to just make sure that the plane does intersect, that it does intersect our stalls. So like right now, it's like intersecting like only one of the stalls, I think, or maybe we'll just do like a lacing points. Yeah, so it's just intersecting one of the stalls. And so if we want it to intersect all of the stalls, then we kind of have to like fiddle around with it a little bit just to make sure that the plane will be passing through everything. So if I come in here, yeah, these are like really small boxes. Let's see. Yeah, I think I'm going to do something different here. I think I'm going to just like edit this parking family really quick, and then I'll just put something in it that'll just make this box like a little bit bigger. So if I take, I guess, I'll just come in here and make like an extrusion, and that will like help us out a bit, just so that we have like a bigger bounding box. And apologies if this is just like blasphemous for some people. It's just like a interesting like way of going about it, I guess. But yeah, so I can go ahead and run that now, and I see all of my bounding boxes are a lot higher, and then we can start to get all of the geometry for these things. Okay, well, hey, I'm kind of confused here for a second, but this Z point, I think, is what's throwing it off. Yeah, so I'm just gonna make a point that's like a little bit higher. I think that's like all it is. It's just like something where we're looking at, well, actually, here, I'll just get a centroid of one of these cubes. And then that could be the origin. Pass that through. Probably don't need cross lacing. Nice. So now we have surfaces at all of these plots. So if we go ahead and hide all of these, now we have just like surfaces for each one of these things. I'll flatten out this list, and we can start to see our interaction between the surfaces and the parameters. So if I get like 0.5, 0.5, then that'll give us the center point of this surface. Go ahead and make that one. Oh, I did not see that coming. Did anyone see that coming? I did not see that coming. Okay, well, I don't know. Hopefully that kind of like gives the idea of like what we would be trying to do. I can just take this back a bit and just use this centroid point and start to adjust it to draw our tag. So I'll pass the points into these locations, and when we run that, we'll get all of these kind of center points along all of these things. I guess I don't really need the square within this parking space anymore for that, but that's okay. And then we could do like geometry translate and start to get more locations kind of around like the center point of that. So we go like this, and then we can say like, you know, just translate it a little bit over to like the right, and we could use like a number slider for that as well. So we do that, and then like everything can kind of start to shift. So as I change this value, F5. So you can use F5 too to like rerun your graph, so you don't have to like pull it up. So if I go for like 1, that'll be like a lot more intense. Everything will everything will start to shift over to the right. And so if I want to like shift everything up, I could do something like that. Or if I want to shift everything down, I could do like something like that. Cool. Is there any questions about that? I know that was kind of like rocky. It is like a weird thing that I experienced, but hopefully that gives an idea of how to start like placing things automatically with a bit more explicit sense of what's going on, or data management, if you will.
Do you, I sometimes like to put room tags outside the rooms, but lined up with each other, and then pointing, so the leaders are varying lengths depending on where the room is, you know? You understand what I'm describing?
Yeah.
Yeah, so here you're moving the tags relative to some point in the object. I'm wondering if you can move the tags so that they line up with some line that you've drawn instead.
Oh yeah, that's a really good one. Okay, yeah, I'll just do it. So like if I get a detail line and I just draw it straight across,
Yeah.
I'll draw it straight across here. How's that? I guess they're all kind of close, but maybe we'll just see like exactly what happens when we do something like this. So
yeah, it doesn't get polished. Just proof of concept is all I care about. So, yeah.
Good question. So I'll go ahead and I'll test it out. So it'll be something similar, I think, to like what we did earlier. So we'll just select that line so that we could get its geometry over here into Dynamo, and we'll have to do like element curves in order to get like the line out of that detail line. So I'll run that, and okay, now we got our line, and then we got like our location points, and so we could just do another like closest to. We know we have to do a lacing longest here. When we run that, then we get all of these points, and the points are like along this line. So if we do this for location, and then we say like add leader true,
Yeah, okay, so
There
a
you go.
little tweaking, but yeah, that was pretty cool. All right, awesome.
yeah. I mean, we could do it like this as well. Like we could do something like this, and then we could filter out based on like how close things are to like one another. So maybe we can just have all the tags that are on these parking stalls go this way, and all the tags that are on these parking stalls go that way.
Sure.
But yeah.
Oh, that's kind of cool. All right.
Yeah, good question. And I could like, I guess, forward you that stuff or whatever. I guess it's all recorded, so you can just check it out. But
Watch it again, sure. But yeah, I mean, you've been deleting stuff along, so it's not like there's a graph for you to save here. So we just watched the recording.
yeah, it's just the musings. It's just my musings, I suppose.
No, it's fine. That's educational too.
Nice. Any other questions, guys? Like, let's hear it.
No one?
Well, with some of these workflows, you have like the guide, like the little spline line and things like that. Do you typically make like a Dynamo work set just to organize these? Or is there like a best practice that you found for these sort of references?
Yeah, I think it's gonna just vary depending on like how involved the process is. So like if we do a lot of workflows, like I know you mentioned Spline specifically, so like, but if we do a lot of workflows with like section view creation and things like that, we'll have like a lot of like very explicitly set parameters that tell the graph like if something's been processed or not. And so that's usually done with like project parameters. And then we'll have like view filters set up and stuff like that so that things could get hidden out. And so maybe that like would work out really well. Like it just depends. I think like if it's something like this, it's like you're going to renumber your parking like in one go, and then you could just delete the spline out of there. But if you do something where you're like augmenting tons of families, or you're otherwise working with like a massive amount of elements in your project and running stuff on them, then I do think that it's very important to have like work sets set up that get set and like pulled automatically so that everything could be corresponding, or you have parameters set up that are just like yes, no parameters and stuff that tell you if things have been documented or not. So like abstractly, I guess, that's how I'd answer it.
All right.
Nice. Well, hey, I mean, I hope you guys like learned a lot here, and I think geometry and like working with Dynamo Geometry is always like a tough training point. Like I've done trainings where like some people just get completely hosed when I go to the geometry part, and like people sitting across from them like work at it really well. So if it's kind of something that's really crazy looking and stuff like that, I think it's something you just dip into, and then you can look back and shoot me some questions or something, and I can help out.